Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. This is a partial fraction decomposition problem, as you can see. It's Halloween, so hope you had in Spanish, Feliz Dia de Brujas, Day of the Witches. Have a great Day of the Witches. But interesting thing about this, I wanted to do one of these. I've done a lot of these partial fractions. I'm trying to clean up, I did these years ago, and so I know so much more about everything now that I clean up every day. I'm cleaning up these programs and doing whatever I can to make them better and better and better. You notice that this has a exponent of 2 down here in the denominator, and the numerator has an exponent of 3. That means you have to do long division on this problem first. Notice if this was x squared and this was x squared over here, that it's kind of short division, but anyways, x squared is 1, and so you have to add a 1 to the partials before you integrate them. And of course the 1 with respect to x in integration is x, so you have to add an x at the end of the answer to get the correct answer. But this one here gets deeper as the exponent gets higher, so you have to use long division. So that's what I did here in my programs here. Index 8 to get to my menu. Remember, you buy my programs and you're told you get the programs in an email, you save them, and you're taught how to load them into the calculator here. Over 800 programs in the calculator to solve calculus. All different kinds of calculus, and you'll pass any calculus test if you have this in this calculator here. So remember that, okay? And you're taught how to put the letters index 8 and open and close parentheses to get the program working in my menu. Goes to my main menu, of course, and then open and close parentheses here tells the calculator that you want to do a program. So let's do it. The menu comes up, and of course you scroll with this cloverleaf here up or down. I've had it set so it just goes to partial fraction to save time on it, but I'm just telling you how things work. Press that, we get into partial fraction decomposition, and we're going to enter the integral here. This is the integral, and you do that by pressing second alpha once, okay, and then you can put all these characters in my programs. In other words, x cubed, etc., plus 5x squared minus 7x. Now I've programmed all this in here just in case, so the simulator doesn't screw up when I put it in, add them in here, and then I have to do the video all over again. So I've already programmed this integral in here, and it's the same spot, same position that you would, and then of course you're given the option to change it or to say it's okay. I say it's okay, and then I factor the denominator for you, which is the true test of a partial fraction decomposition problem. If you can factor the denominator, then you're into partial fractions. So remember that, okay? And because the numerator of the exponent is higher in the numerator than the denominator, long division is required. I tell you that. So here's long division. Here's the divisor. Here's the dividend. We're looking for the quotient up here. We're going to divide x squared into x cubed here. And when we divide x squared into x cubed, we get x. So the quotient number 1 is x. I have to do it this way because of the small screen on the calculator, so I have done the best I can to show you exactly how to do this. Now we take x and we multiply. Here's the original integral here, the numerator. And we take x and multiply it times the divisor It says x cubed and 3x squared plus 0 is 0. You have to add the things that are missing, of course. Here's x missing and the last term missing, so we put 0 0. We subtract it. Notice the subtraction sign here. These are all subtracted. Turn out to be this. Now we divide what we just found by x squared again. Equals 2. So the total quotients now are x plus 2, okay? And fourth, we multiply 2 times the divisor. And we get 2x squared plus 6x plus 0. We subtract that, we get minus 13x plus minus 1. The problem is finished in any long division when you can't divide the x squared here into any more terms of what you found, okay? So the problem is over. So then turns out the answer is x plus 2, which we found as the quotients, or the quotients. And then here's the remainder, minus 13 minus x minus 1 divided by the divisor. All right, so now we go and set up the problem for partial fraction. Here's the left side of the equation, minus 13x minus 1. We multiply over the divisor. We multiply times the divisor. We're trying to get rid of the numerators, or the denominators here. And a over x plus b over x plus 3. That was the factored terms that we got at the beginning. Remember the factored? Multiply that times the factor, and they switch signs on the bottom here. So it turns out to be minus 13x on the left side of the equation, and then a x plus 3 on the right side, and b times x on the right side. Now at x equals 0, you figure out that in each partial fraction how to get rid of certain terms so that you can figure out what the other terms are compute to. So in this case, if we make x equals to 0, then we'll get rid of the b term here and keep the a term. So we do the math on that, and a is equal to minus 1/3 then. You know, we're multiplying the left side of the equation with x equals 0 too. Of course, that turns out to be minus 1. And then we want to get rid of the a term, so minus 3 will do that. A minus 3 plus 3 is 0. So now we take the left side and multiply, turn in the x value on the left side. We turn out to be what you see here, 38, etc. We do the math, b is equal to minus 38 over 3. So now we go back to the original partials and put the a and the b in for that. A over x and b over x plus 3. All right. So the integrals are x plus 2, which is the quotient we found from long division, plus the integral of minus 3 over x and minus 38 over 3 over x plus 3 dx. So the answer is this, x squared over 2 plus, when we integrate, minus 1/3 times log of x plus 3/8 over x times log of x plus 3 plus c. Pretty neat, huh? Everystepcalculus.com. Unbelievable program, unbelievable. I love doing this every day just because of MIT, who invented this program into the TI-89 system, the Texas Instruments system. Unbelievable. It knocks me out that it can do all this all the time, you know. And so, good luck in your classes. Go buy my programs and pass calculus if you want. Otherwise, you can study this stuff for. I've been in this. I will say this statement, which is a pretty profound statement, but I've been doing this 30 years. I've never found one useful problem in calculus. Useful. There's a million answers like this one right here, like this answer you just got right now. But what's it used for? Nothing. You know. So that's what calculus is. I've always been fighting that. It really pissed me off when I got into this thing. I said, what the hell's going on here, for God's sakes? After you program, and of course I have to program every little thing, every plus, every minus. You change this minus sign here to this minus 5, and it changes the whole problem. So you have to, It's extremely complicated, but I enjoy doing it, and of course I enjoy helping you pass calculus, or anybody you know pass calculus. So buy my programs and pass calculus. I help you also. You can call me on the phone. I'll help you with calculus. I'll help you with how do my programs work, whatever, you know. My physics programs came because one guy from Long Island paid me $3,000 to program his test for physics. He was a 50-year-old man and obviously had a lot of money and wanted me to program his physics test. So I did that and paid me $3,000 for it. So then I kept doing that. So my physics programs are unbelievable also. So keep that in mind too. Hey, have a good one. I hope you have good luck with your classes.